Welcome back, ladies and gentlemen. This is part 2 of our text adventure game we're going to write. I'm going to check this out again real quick and see. It does look like it's the same again. Okay, I thought maybe this had multiple different stories, but I guess it's just one story. Okay, interesting. Let's get back to our game, though. If you'll recall, we had... where did my browser go? There we go. Here we go. We did a little bit of work setting up the... We did a little bit of work setting up the types we're going to use, and we're getting really close to getting this done, and then we got to get the import and export working. Yeah, and then we're going to make progress. So, let's do a little recap, first of all, of what we've done so far and what we have in mind. I think it might help to make this smaller. Oh, wow, okay. Let's do that. Good enough. And boom. And you know, we might do it like that. Okay, so we can see both of them now. Okay, keep this on top. Let's try drawing. I got my drawing tablet out. Let's try using it, see how that goes. Alright, so the way this works is we've got our rooms, which I'm going to make them rectangular. They could be circular or whatever. We got our rooms out, right? And there could be, various rooms here. And they're all going to be connected in various ways. Let's see. Okay, let's try this. These can be connected here. Okay, well, that didn't work out very well. Is there a line draw tool? Probably not. Let me just use the rectangle. They're going to have a path between them. And the path might be, well, that's not going to, the rectangle's not going to help us there. Okay, well, let's just draw with this. Alright, you might have a path like this, and a path here, and maybe a path here, right? So you got all these paths connecting various ways. You got your room. Inside your rooms, you'll have some objects of some kind, some kind of tools or supplies, maybe a screwdriver, a crowbar, maybe some lunch or something, maybe a knife or a sword, right? You got your items in there. And you might also have interactive elements, interactive portions of the room. Like maybe there's a big switch with an on-off button. Maybe I don't know how to represent that really. That's okay, we'll have an on-off button, an off-on button. Anyway, whatever. You have all this different stuff there. You can interact with. It's attached to the room. That's one thing we haven't added yet. We have an inventory for our rooms. But we don't yet have, interactive elements. I think I'll just call it interaction points. I think that's a good name for it. So a room can have interactive areas. I don't really know how to describe it. I don't know what the best way to describe it would be. I think just to keep it simple, though, we can have, for example, hub interaction. Oopsie. Okay, let's not make this on top anymore. I think I don't know what to name this type. That's probably the wrong name, but yeah, let's take out the word point, right? It's an interaction. We're defining an interaction here. Now that should... Here we go. That type checks. Great. I think what we really want to have here is some kind of label. Well, we need an ID, right? We know those should have IDs. Just give everything an ID. Maybe there's some kind of a description as well. Oopsie daisy. And then we're going to have some sort of behavior that the user can do. Some sort of action they can perform against it. And an internal state. You know what? Maybe an interaction should be a trait rather than being a specific type of thing. I don't want to make it so complicated, though. It doesn't need to be flexible. inside Rust. It needs to be flexible inside the story. Like, we've got two components of a text adventure game. We've got the game engine, which we're building now. That's what we're working on. And then we've got the game itself, the game description. They don't both have to be flexible, but what you want is you want to have the user have a cool experience, right? You want to be flexible enough somewhere to give the user a cool experience. And I don't think we need to be flexible in terms of, it's not a matter of considering the API inside of Rust. We just want to, we don't need the type system to be fancy right now. We'll just keep it simple and just make interactions. So how would I represent that? What's a simple way to do it? Well, fundamentally, I think the point of an interaction is to modify a bit in, like, I think the simplest form of this is you want to modify a bit in the public space. You know what I'm talking about? Like if you have an on-off switch, right? Here, let's try drawing. Let me get used to this, right? Maybe I'll be better at it next time we. Okay, can I? Maybe I'll be better at it next time. All right, I'll just keep practicing. So let's say you have, pen upside down. Here we go. Let's say you have something like this, and then you've got it. Oh boy, I'm really bad at this. Okay, I think the problem is it's not level. Let me get this level. All right, let's fix that and then undo. All right, this is going to be better. Okay. Okay, yeah, you got your switch, right? And here it's off. Hello. And then on. It's really weird typing with, or it's really weird drawing something without looking. Okay, is this a text box? Is that what that is? Yeah, it is. Oh, I can type. Good. Off/on. There we go. Okay, cool. I can do things like that. Anyway. Let's delete all this then. Oopsie, deleted too much. That's how life goes. You got your switch here. One side is off. The other side is on. Text size. We'll crank it on up. Oh, wow, I like having the... Yeah, that's good. Cool. Crank up the text size. There we go. Nice. Let me learn how to use this tool. This one. Anyway, whatever. Okay, so you got your on-off switch, right? This toggles a bit inside your world somewhere. And, yeah, excuse me a minute. It's really dry in this place. I gotta solve that. Anyway, you've got your on-off switch. It's going to control a bit of your world. And this has got to modify global state in some way, or at least state local to the room. Now, right now, we don't have the idea of room local state. Yeah. Okay, give me 5 minutes. I'll be back in a second. There we go. Okay. Unfortunately, this room has the best access to the AC, which largely means it's going to be the driest room. So I walked into my streaming room, got caught off guard a little bit, just thinking, hey, I'm just going to stream, right? And then it started attacking my voice. So that's all right. We'll get adjusted in a few minutes. And I made some changes We'll get that all ironed out. Anyway, pardon me while I struggle through. So we want to modify, like you flip a switch, maybe a light turns on, maybe some sort of thing happens, right? Oh, come to think of it, there are two different kinds of interactions. There's interaction and observation. I feel like we need, you know what we need is an enum. I don't want to get too fancy with it though. But we want to basically represent state changes, right? Yeah, that's what we want. Oh, you know what I realized? We had this idea of a label and description everywhere. So we're just going to make a struct for it. Pub struct description. And then we're going to have these two go into there. Man, I'm making so many changes here. This is not going to have it. Okay, so we're going to have a pub description. There we go. Same thing here. Pub description. Now let's keep that. Okay, I don't see label anywhere else. Is description? Good. Okay, so now description is going to be a separate object. And that's going to help us with our Now, we have two different kinds of things here. We have interactions and observations. An interaction is when the user can hit a button, right? An observation is if you have a light that comes on, right, in the room. So these are things that can change. This is where you have some sort of state that can change. And that state can either be limited to the particular room, or it could be connected to another room. I don't really want to think about how to hook them up quite yet. I think that'll be separate. I don't think we're going to put that sort of mechanism into these types, but we're going to have to store that somewhere and handle it somewhere. It probably will just go in the world, to be honest with you. We'll have players, rooms, and maybe interactions will be a separate, or interaction connections, or state connections, whatever we're going to call it. It'll be a separate thing. Okay, so an interaction is going to have an ID in the description. But what would you call the concept? Oh, the text size resets at 20 each time. That's a shame. Of an interaction or an observation, right? Let's think. I got to think about this a minute. What really combines those two concepts together? It is the concept of state changing. Maybe I could just call it state. But the problem is that's so generic that I'll get confused later about what it means. Let me think about this a minute. I'll be right back. Okay, so state, let's call it state for now and just move on with life. I can't remember how to do a nums too. Let's just get a quick example of that so I remember. Show me a short Rust enum, no comments or explanation. Just something real nice and short. Great. Yeah, syntax-wise, there we go. We have an interaction, or, okay, comma, or we have an observation. Now the question is, do we want to have more than a bit of information available for each one? Because we need to attach behaviors to these, right? Well, let's handle the basics. They're both going to have IDs. And they're both going to have descriptions. Maybe I don't need to put the state here. Or even if I do, I need to figure it out later. Can't be pub. Why? A num variance in their fields are always share the visibility of the num they are in. Okay. Well, that's a bit different. Okay. If I put pub here, I imagine that's also disallowed for the same reason? It just says syntax error. Interesting. Okay. Yeah, I think what we're going to have to do as a to-do item is we're going to have to figure out how to handle state management. And really, this might be... The best thing to call this might be like a user... Interaction might be the best name for it. But that means I have to come up with a more specific name for this. So maybe AI can help me with that. Okay, let's clear this. Okay. Okay. When a user modifies an element of a system, what's a good generic name for that? For that concept? Let's say term. It's going to give us something wrong. Yeah, it's not even close to what I'm not describing what I want very well, I imagine. Synonyms for interaction. Let's go with that. Keep it simple. Engagement, interplay, connection, contact might be interesting. Okay. Synonyms for interaction in the meaning of something the user can affect or change. This isn't quite coherent, but let's see what it comes up with. Manipulate. Oh, manipulate. Okay. Adjustable, manipulatable. I feel like manipulatable is a good place to start. Let's go Wordnik. Let's look at that word. To move, arrange, operate, or control. Operate. Operate or observe. Okay. Operate's a really good one despite the alliteration. Okay. Let's just change it to a verb. Operate, observe. Okay. Yeah, I think that's really good. Okay, now what's wrong with this? Define multiple times. Oh, okay, yeah, we can get rid of that real easy. Perfect. Now then, interaction points. I don't think points is necessary here. It's not like a physical point. It's like interactive elements. Okay, let's see if it can help me here. A word that means interactive elements. Widgets. Features. Features is great. Features. Room features are things you can interact with. Okay. It needs work, and this also needs to be a vec. The name needs some work. Features of the room. Yeah, okay. Give more synonyms. Modules, interfaces. Interfaces isn't bad. Elements. We could just call it elements, yeah. Gadgets. Controls. Functions is a little bit too easy to confuse. Okay. Synonyms for features. Attributes, qualities, faucets. I like faucets too, but it's a little bit mysterious. Aspects. Well, features are interactive elements, right? I don't know what to call it. I could call it interactive elements, but that just is really wordy. Okay. What's a shorter phrase? Wait, didn't I already start from there? Yeah, I did. Okay. Whatever. We're good for now. Now, I do remember last time we had this transfer to function. The whole idea we were going to have put item and take item be internal, to where basically you can't remove an item from an inventory unless you're going to put it into a different inventory, and you can't add an item to an inventory unless you took it from another inventory. It's probably too early to give myself this kind of restriction, though, to be quite honest with you. But I think I can go ahead and set the restriction in place, and if I find myself needing to pull items out with take item and put item, I can just make these public, right? I feel like this is just a code smell to me. Well, it's not a code smell. This is me noticing my own tendency to design an API and lock it down too prematurely. Having said that, one of the primary use cases of putting an item in inventory, or one of the primary use cases for taking an item or putting an item, is to transfer it from one inventory to another. But by making these private and this public, it basically am saying that the only legitimate way to transfer items is via the only legitimate way to put an item. Like, items must be transferred between inventories. It can't be invented from whole cloth. That might be good. I mean, I can think of story reasons why there might be some items that appear in a room that didn't. Anyway, we'll figure it out. To be honest with you, it's not that hard of a limitation to get around if I really want to. Because if I want to put an item in an inventory, I could just create a new inventory that has that item, and then do a transfer. And if I want to remove an item from a room, I could just create a new empty inventory and transfer it the other way, and then just delete that inventory. Since it's so easy to hack around it, I think what I'm going to do is go ahead and make all of these public. Since it's oopsie daisy, yeah, I'll just make it public since it's so easy. Even with the transfer command, all you need in addition to transfer command is a new command, or a new method. Sorry. Yeah, if you combine a transfer and a new method together, you can emulate these two. So it doesn't make sense to try to hide them, because I'll have legitimate reasons why I'll need to do that. But I want to make transfer available so that if the programmer, which is going to be me, needs that safety or wants that safety or just wants the convenience of not having to do it themselves, they can have it. So that was a really long way of saying same as self. Result and static str. Now, I think with a static string, you can still use a format string. Oh, no, you wouldn't be able to. I mean, you can use a format string, but you have to only use literals. Static string is probably the wrong error type to use, but it's convenient for the moment. And we'll go with that. Okay, so here's what we're going to do. We want to transfer an item. Oh, yeah. From self to other. Wait. We don't want to call it other. Destination. Here we go. And we want to... we need the item, right? This takes an item. This takes an item ID. Okay, we need the item ID. And ID. Okay, great. Okay. So we have let item is take item, self.take item by ID. And we want the question mark. If there's an error, we want to propagate it. And then we want to do put item. Oh. Destination.put item. Item. Question mark, and then OK. Now that's failing why? Oh, there's no... Oh. Take item is... Oh. Right. Take item returns an option. Unwrap... Wait. Unfortunately, this isn't going to give me information about this from Rust Analyzer. Rust Analyzer is still broken. I need to take time to sort that out. Let's see. Okay, well, I know one way to do this. It's going to definitely work. Let's not overthink it, right? Oops. Else return error item doesn't exist in source self. There we go. Perfect. Done. Now, we got this transfer to available. Like I said, we can emulate these very easily. We do want a new as well, I think. But new should be the first one. New. And it's going to take some arguments. It's going to return a self. Okay. What arguments does it need? Well, it needs the max capacity. And it needs a storage, right? I guess I could build the hash map outside, but I think it might be easier. Let's check out the hash map API again. Do I have another tab open? I don't. Okay. Here's where I was. It says I can switch the tab. I don't see it. Oh, right. I moved it over here. Okay, great. Let's look at You know, creating an empty one makes sense, I think, but no, I don't think I think realistically we're not going to create empty ones that often, are we? Let's look at all the toHashMap functions. With hasher, okay, I'm not really interested in that. Default, an empty, okay. From iter, this is what I really want, is from iterator. Yeah. We still need a capacity, I think, unless we just assume the item's full. Yeah, I think we need to implement the from iterator class. Yep. So we're going to do that. Okay. Let's just keep it simple for now. Well, actually, let's go ahead and use this. Let's use K. Let's call it I. Right. Where, oops daisy, I is from iterator, KV. Yep. Okay, what's K and V? It's going to be ID and item. Right. Okay. Looks good to me. I like this. All right. Now, what I definitely want is to use this from iterator and implement that. We're going to do a to-do right here. I do feel like we're getting hung up a little bit too much on the weeds trying to implement this. I don't know, it grabbed my attention for whatever reason. I guess I'll finish it, but yeah, I do notice that. Okay, so implement from iterator. Let's see. KV for inventory. Use hash map dot hash map from a tier to build the storage and use the storage length as the max capacity. Should be good. Yeah, that was super simple to build. That's incredible. Okay, so we got our iterator T. Why are we calling it T? Okay, into iterator. Oh, okay. So it's not quite as restrictive as what I wrote before. So let me look at my code instead. Here we go. Get rid of some of this. Okay, so let's call it into iterator. Okay. Item equals that. Okay, we could use T again, but I don't really see how T is beneficial there. Okay, storage. Great. Now here's what I want to do in this case. Is I want to do let result equal self from itier items. That should work. And then let's just return result. Or let's just put result at the end. Obviously, this doesn't do quite what I want. I don't want to just duplicate it. What I want to do is set result.max capacity equals max capacity. Wait a minute. Assert that results dot daisy dot storage dot len is greater than or equal to max capacity. Here we go. If not, it's a programming error. Yeah. And then we're going to set that. There we go. Okay. What do I want to name this variable? I guess result works. Instance, maybe. Makes enough sense. I want to call it self, but I know that doesn't work. Okay, why didn't this change? Very interesting. All right, yeah. So I think we're done with that then. We got our new method. Oh, okay, that's exciting. Why are we... What? Great. Things should build at this point, I believe. Let's try it. Let's try it. Okay, just a second. I'm going to make a slight tweak to my life. Let's see. Huh. Oh, right. Perfect. Better indeed. Okay. Cargo build. Oh, wow. Okay. What changes did I make? A lot of changes. I think I can break them up. I'm going to wait about those. I am going to... Yeah. Let's take our time with it. Do a good job here. No, you know what? No, we're burning life away. We're burning hours in the day. Let's not. Okay. Doesn't have to be perfect. Okay. I need to fix that at some point. I guess at some point I need to do a stream about rising my setup and fixing everything. I know what the issue there is. Nix is really cool in a lot of ways, but it takes a lot of extra work to get software set up. And for some reason, yeah, I haven't been able to get rid of all the issues in NeoVim. I'm having a different set now than I was before, so that makes it even better. Okay, so add interaction type and refactor and factor out description type. Many objects have a description, a label and description. So we factor those fields out into a new type description. It'll allow us to share code too. Like any routines we make from manipulating the description of a room can also be used for manipulating the description of an object or an interaction. So that's really good. Add the interaction type to complement the item type. Items are things the player can take. Interactions are things the player can do, see, can do or see change. Let's say modify. Okay, we're going to leave this alone for now. Okay. Flesh out inventory API a bit more. Add from iterator, oops, new, and transfer to. I just realized that transfer to is a little bit confusing. I meant for it to be spelled like this. Let's say room.transfer to player. Here's the way I imagined it. And then we got the item ID. Right? some item. And that looks okay. But when you do room.transfer_to, and you just look at that, it kind of looks like we're transferring into the room. I can see myself getting confused either way. I don't know. I think it's slightly better the way it is. Slightly better. It just means when you're looking... Yeah, it can be confusing when you're looking... When you're looking through the list of methods, it might be confusing because you're like, oh, transfer to, that lets me transfer into it. You're like, no, it lets you transfer out of it. Transfer between doesn't resolve it, so you may as well just say transfer. Yeah. Okay. So, what do I lack here? I think we're getting pretty close, to be quite honest with you. And one thing we definitely lack is to give some meat to these interactions. So far, we've just given them a description. An ID and description. That's nothing. But what we need to do is have basically a function here that lets you modify the world. And I don't know a neat way to express that as a... I don't know a neat and tidy way to express that in a JSON file. So that means we need to describe... We need to enumerate all the interactions we're going to allow, and then we have to implement code for them. So we're going to have a big switch statement, essentially, or a match statement. Yeah, that's going to be a lot of grunt work, but I guess AI can help me with that. And I want to keep it dead simple. What this conversation is indicating to me is we need some kind of state object in the world. We need some kind of data type inside the world contains it, with some kind of global state that can be modified by these interactions. It also would be good to have room-specific state as well. And I don't know what the form of that state would be. But it kind of almost doesn't matter, right? Like, we need interactions to be... We need to be able to change state with operate, and we need to observe state with observe. It doesn't matter. I almost could change this to modify, but anyway. Maybe that's better terminology. I'm thinking a list of integers is probably a good place to start. You know, an integer can represent true or false. Yeah. Or maybe we have a custom one. You know what? I think this is worth digging into, and now's not a bad time to do it. So let's make a new file for this. We definitely need this. Interactions. And we're going to drag some stuff into here, because this is going to take up a lot. So, do I want to rename that to interaction? I think I do. There we go. Be consistent. Why are we... What in the world? It's already open. Don't open it twice. Boom. Oh! It needs to be... Okay, Rust. RS. Wow. No wonder I called it interactions. Okay, insert... Hub mod. It's not going to be crate wide. This isn't a library anyway. Import... Whoa, hello. And then this should import to... Oh, the description is set as a string. It needs to not be a string. It needs to be a description. Oh. There we go. I still have description string right here, but I don't think I have anywhere else. You know what? The player's going to have a name. They're not going to have a label. They're not going to have a description with a name and a label. Yeah, they're going to have a name. They're going to be special. Descriptions are like that. Okay, good. And this is one of the cool things about Rust. It does let you, I think. Okay. Let me try building it and see what I get. ID is not found in the scope. Well, that's problematic. Let's fix that. Yeah, it works. Okay, I don't know why it was complaining. It must have been out of date. Okay. Great. Now we moved interactions out. Right. So we're going to have state. Interactions are a way to modify state. Are the player's method of observing and modifying state within the game. Non-player characters, NPCs, interact with the world in a similar manner. Okay, now pub struct oopsie daisy state. Right. And we're just going to call this state. And it's going to be a vec of interacted. That's a bad name. We're going to fix it. Pub enum interacted. But I need time to think it through. Okay, so each one of these needs some kind of ID. Well, here's the thing, right? We want to be able to find these interactions before... I need a better name for that. We're going to call it llama. Okay, it's a llama for now. We'll figure out a better name later. But now let's talk about it. Okay. When you start playing, you're going to have a llama up here. Pub, state. Yep. Okay. And then you're going to have state for every room as well, right? Now, you might have state for the player as well. Oh my goodness. Yeah, we'll add that later. We're going to focus on the world in the room for now. Okay. So, when you start with a brand new world, the state is empty. And when you have a brand new room, the state is empty. Nothing's happened yet. Everything's default. Okay? So then when you operate or observe, it's going to modify the state in some way. And what it's going to do is add a new element. It's going to add a new llama to the state vector. And then that llama is going to be configured in a particular state that means something significant. Like you might have a room that has a light switch and a light. You walk into the room, the light is off, the switch is off. You flick the switch, it inserts a llama saying, hey, the light should be on now. And then the light itself is an observable, right? So you have an operator on, maybe we should call it operators and observers. Yeah, maybe we should do that. Yeah. I like that. You have an operator on the switch to insert a llama saying, hey, the light switch should be on now. And then the light switch has an observer looking in there to check if it's on. Right? And it's going to have a default value as well. Okay, I don't know why these are on one line. Did I do that? I don't think I did. I feel like that was outside my control. Okay, we'll just get this tidied up a little bit. Oops, come on now. Oh, geez. Okay, I can code, I promise. Oh, come on. Undo. What in the world? What? No. Okay, gosh. That's frustrating. I don't know why it's reformatting it that way. Right. So, To be honest, yeah, okay. So these are going to have the same types, though, inside of them, so maybe I just need a subtype. Yeah. There's not really a huge difference between operator and observer other than this tag here, to be quite honest with you. So maybe I should need a struct for it. Okay, so pub, struct, interaction, struct. There we go. Interaction, description. I don't know. That's a really wordy name, though. Description? Wait. Let's try A. Okay. Interaction description. Yeah. Okay. Great. Pub, as far as I'm concerned. Okay. Now, interaction common. You know what this is speaking of to me? Yeah, I need to do something different. Interaction type. What I need to do instead of this is backwards. Well, no, let's not go that far. What I need to do instead is have a pub, type, iType. We'll just call it iType. Okay, great. This makes more sense. Okay, great. This is making a lot of sense. We still need to name llama. So, yeah, and there's going to be something here. An observer is going to have a default value, right? But both of them are going to know the time. This is getting a little bit tricky. Okay. There's an idea here. Just wanting to come out. It's... Yeah. We'll get there. I know we will. I have faith we can get through this. So, the key here, though, is we want to keep this really simple and not complicated. We want it to be simple and powerful enough, right? If we make it simple, but then it isn't versatile, then it's not really useful. That means it'll be complicated in the end when we keep adding stuff to it to make it do all the stuff we want. If we make it simple and powerful, then we're done at that point. We just leave it alone. I'm thinking we want to have... I think there's a lot of power in having only one type of state, actually. Yeah, okay, so here's what we're going to have. Default. Is that allowed? It is, okay, so it's going to be a llama. The idea here is with the observer, let's say you enter the room, there's a light switch and a light. You know, we should just draw this out. Instead of me talking about it, let's just draw it out. Because, yeah, here it is. Let's get rid of that for now. Okay. Let's just draw it out. Okay. You're entering a new room. Okay. Inside, oh boy, let's try drawing again. Okay. Here. You know, let's make it bigger, actually. 25. Okay. Let's not drop our pen. So at the top, you have a ball. be dazzled by my drawing skills. It may be radiating light. You don't know. You don't know. It could be. And over here you have a light switch on the wall. And yeah, that's really horrible. I need to make that better. Hang on. I can do better than that. Why is delete not working? There we go. Let's get rid of it radiating. Yeah, let's just start over. I can do better. I have faith. Oh, that is not even what I wanted from life. Okay, that's a decent light. It's an incandescent floodlight, but whatever. Then we have our light switch, which, whoops. Let's do this with the mouse. It'd be way easier. Oh, okay. The outline size is really. It really varies about the sizes. Okay. Let's use this one. Let's erase this thing and that thing. Great. Okay, today I'm just going to use the mouse. We'll learn how to be cool and use the drawing pad later. Okay, so we got our light switch on the wall. And actually I got it in the wrong position, I just realized. Let's just say it's off. Okay, light switch is off, lights off. Okay. Now, when the new room is created, the player enters the room, the state is empty. There is no state. So you go here and you've got your room, okay? It has two interactions. Oh, this should be interaction. Okay, it clearly doesn't know what it needs to do. I can do it manually. What? Oh, let's just call it interaction. There we go. Perfect. All right. So we have an interaction type, or we have our state here. It's empty, right? There are no llamas in the state. Now, the light bulb. How does it know whether it's on or off? Well, it has a default state. It has a default llama, so it knows. Hey, this is an off llama, so the light's off, right? It just has that stored inside of it. So in the room, you have the features. You have two interactions here. One of them is a light bulb, and it's off, right? So that's this. Actually, can we? Yeah, I think we can. Let's bring this over. Okay. Two interactions in room. Light. Default state is off. Oops. Switch. Yeah, switch. I guess the switch is going to have a default state too, actually. Interesting. They're both going to be off. Okay, here's the challenging thing. When the switch inserts the state into the room to say, hey, on, it needs to somehow reference the state in a way that the light and the switch both need to look at the same state variable. This is just implementing variables. Okay. I know the name of variable. I know the name of llama now. Variable. And it's not going to be an enum. Oops. It's going to be a struct. Label. We might have a dot comment at some point, but we're not gonna do that at the moment. We have a label, which is going to be how it's referred to. This is just yeah, we're implementing a programming language. We don't need to overthink all this stuff. Okay, programming language. And then yeah, it has a label. It's going to have a value. There we go. Actually, it needs to be an I32, come to think of it. Oh, we need a comma there. That's our problem. Okay, great. We'll make those both pub. Yeah, there we go. So, both of these need a particular... Okay, we need a particular variable. Label. String. This is the variable we're referring to. And we need a default... Okay. Pub default state. Pub type variable value equals I32. Probably this will be some sort of a enum at some point. Let's abbreviate it. Value. Default state is a value. Great. Now we don't need default state here anymore. Because the operator needs a default state too, right? Because there's a visual indication on the operator, generally, like if you have a switch, right? You can look at a switch and know whether it's off or not, right? So, now some things like buttons, for example, if you have a button in your life, you can press it, you can press it again. You don't know what its state is, right? Some buttons, you depress them and they stay locked, down. Some buttons, when you press them, a light comes on. But some buttons, you just press them and you don't really know. Like most buttons on your keyboard, for example, you just press them and a key shows up on your screen, but the button itself doesn't change in any way to indicate what happened. So it's sort of like if you had a push button light, the button wouldn't change, but the light would come on, right? So it's kind of that. But a lot of times you're going to have a state change in the operator as well as the observer. The operator being the light switch. Okay. Let's make that clear here. The light is an observer. Switch is an operator. And we are very directly defining a programming language. Like, we're literally going to use these terms when we're describing to the end user when they're creating their game. This is how they're going to do it, right? And so, yeah, it's very directly the language we're going to use for it. Okay, now there are some differences between an operator and an observer. What an observer needs is a mapping. Because this is a text adventure game, and the user sees things by reading text, what we need here for the observer is we need a mapping between every valid state of the variable and the string that should show up. Okay, so we'll call these observations. Pub. It's going to be a hash map. Oh yeah, it is. Observation equals, is it going to be a struct? Type. It's going to be a type for now. We'll figure out what we need later. Hash map, which we need to import from value to string. Perfect. Okay, that's an observation. Now an observer has an observation. All right. Yes. So that's the idea. Basically, see this light switch? It's off. The light is off, right? This might be one observation. So if the variable might be called switch, or maybe the variable will be called my light, right? And if the value of my light is 0, the description might be the room is dark. If it's 1, it might be the room is brightly lit. By a multicolor, by a floodlight. Let's just go with what I drew. There we go. or the floodlight makes the whole room look washed out. Right? That might be the two values, right? Either the light's off, the room is dark, and you can't see clearly. The floodlight makes the whole room look washed out. Now, what I might need to do at some point, is if you can't see the room, you probably can't get the normal room description. It's like rooms have a description. If you can't see, then you probably can't get that description. That might be something I have to tweak to get that working. That's going to be a later problem. For now, we're not dealing with that. Anyway, but yeah, basically this is variables and values. Okay, great. So, I guess for the operator, I'm going to try to also do a hash map. Let's see, a mapping. Operation. Hash map. Oh, yeah. Value. It's a mapping from the existing value to the new value. So, for our switch, this is going to be our observer mapping, right? And we might be running a space here. And then we're going to have our operator mapping. If the light is 0, we move it to 1. If it's 1, we move it to 0. This is basically a truth table, right? It's basically an inverter. Like, if you flip the switch, and the switch was off, you turn it on. Yeah. And come to think of it, you might actually have an observer on the light switch and on the light. You might have an observer on the switch observer. You might have a switch on it. Oh, okay. That doesn't help. Here we go. You might have a switch on it that says, hey, 0, the switch is off. 1, the switch is on. Right? You might have that. Although you don't need it, right? Because the light already tells you that, and it's kind of redundant information. You kind of assume the light switch. If you flip the light switch, and then if you go into a room, and you see there's a light switch, and you know there's a light switch, and it says the room is dark, and you can't see clearly, you can infer the state of the switch. And then if you flick the switch, and it says the floodlight makes the whole room look washed out, you can also infer the state of the switch. You don't need an observer on that. And honestly, as a player, it would be a little bit weird to have that description. But if you flip the switch and nothing happens, you might have the switch is down. You flick the switch is up. That might be the only thing that happens, right? Or even better, it might be something like this. You see a switch on the wall, and then if you flick it, it says the switch toggles up, or something like that. The switch is toggled up, or the switch is toggled on. Maybe, yeah, something like that. Anyway, you get the idea. Okay, so now we figured out what a llama is. A llama is a variable. I knew there was something here. Okay, now all variables have an integer value. This is going to be an intentional limitation of our language. Basically, the user is going to have to interact with integers in order to define things. I think this is going to be okay. I think if the user has a mapping like this they write out, like they're going to have to write out these mappings, I think this is completely reasonable, right? Using strings here would make it more difficult, and you can see we're representing true and false, right? It's very clear that we can do that. And honestly, if you'll notice, here we're implementing true and false. Like, yeah, we're implementing, we're inverting the signal, we're inverting the previous state to make the new state. And here, we just use those states. So, like, there's no real need to have a more granular type, right? We have basically a number to represent every potential state the room could be in, or the light can be in, rather, the mylight variable. And then we have a description of what each state is like. I don't know how you could need more than that. Now, you might want a convenience, like you might want to rename these you might want to call this off instead of 0, right? Or you might want to call this on instead of 1. I could see maybe using string here. But then you have a string, colon, string. I think it gets a little bit confusing. Yeah, I think we're going to leave it as integers for now. We'll figure out what to do later. But yeah, this is nice. I think we've got this good, and I think this is good. We need to figure out where to put the operation and the observation, though. Oh, right here. This is so funny. Oh man, I love this. I love this because now I can define arbitrary operations in terms of a mapping. You know what this is? You know what a mapping is? It's just a function, right? It's a manually specified function where you're saying, if x is 0, y should be 1. If x is 1, y should be 0. This is just a function definition, but it's something the user can type out rather than having to have code that we compile. The user can just type this out. We can parse it. We don't have to compile it or anything. We just parse it as a JSON or something. And now we have this neat little function. We have this function between these two mappings. We have a function that turns the light on and off. How charming is that? Yeah, it's just a function. That's what a function is a mapping between input values and output values. So, yeah. Anyway, I'd like to come up with a better name than state, but I think we're good. I think we're cooking right now. I don't want to... I sort of don't want to jinx it. Like, I don't want to mess with this anymore. I want to move on. Okay. We want to add source interaction. Oh, we have... Okay. Yeah, we'll do that. Split. Yes. Edit. Oh, boy. Get rid of this for now. Nope. Yes. Yes. Okay, whatever. Flesh out interactions. Okay, we want to go ahead and put some more information in here. Change interactions to a struct instead of an enum. The enum is renamed interaction type. Observers and operators share more fields in common than they are more alike than different. Easy to say. That's our reasoning. Okay, so what else did we do? Add state structure and express. Here we go. Express world. Oh, whoopsie daisy. World and room state in terms of variables with integer values. We want to go ahead and allow negatives. That's fine. Yeah. Okay. So, we maybe, you know what? No, we do not want to allow floating point at this stage. Can you imagine if we introduce floating point, how much more complicated this gets, this scenario right here? I don't see a reason to use floating point at all right now. I guess if we want to simulate something being analog, then we would want, we'd need floating point for that. To simulate like finely grained changes of value. But I mean, it's an I-32, you can go up to like 30. You can go up really high. What is it? I think it's like 2 million, right? Like I think 16 bits is like 65,000. I think this is 2 million. Anyway, whatever. Point is, it's a big number. Yes. Your values. Observers are a mapping between the current state and and description of that state. Operators well, let's just say observations. Operations are a mapping from the current state to the next. Yeah. Each valid state, there we go. Each valid state, a description of that state. Good. Whoa. Did we catch everything? Roughly. This exercise persists in emulating a programming language. Yeah, that's close enough. Okay. I do need some sort of graph in order to represent room connections. And what I want for my graph is, I know what I want. Let me just go ahead and type it out, although I'm hoping I can find something that will work. I want to have named, oh gosh, it's going to be directional too. Okay, so pub connection. What do you call it in a graph? You have edges and vertices, right? Edges and nodes. Graph edge. Now, I don't want to write this myself, but here's what I want, right? An edge is going to have pub node 1 is going to be a room. Node 2 is a room. So basically, like, a hallway connects two rooms, right? That's what this is, right? It's a hallway connecting two rooms, or it's an entryway, or it's a door between rooms, or a way to get between rooms. But it could be one way. You have your direction, edge direction, edge direction. We'll go back to that. You also have your label. Wait. The label's going to be different depending on which room you're starting from. This is tricky. The label should be the command the user takes. The label should be a command the user can give in order to enter that room, or to use that edge, or to traverse the edge. Yes. So if the user is if the player is in room 1 and they want to traverse to room 2, they should type in the label as a command. So something like north, south, east, or west. The problem is, if you're in node 1, north might be the right way to go to get to room 2. But north is probably the wrong way to go from room 2 back to room 1, right? So you probably want to go south at that point, or maybe south next. Maybe. Let's come back up here. I love being able to draw. This is nice. Okay, we'll come over here. Let's say you have your two rooms, right? A normal way to connect them might be like this, right? Connected like that. But you could have rooms connected a different way. Instead of that, you could have this. This is also a valid connection point, right? Or you could connect them like this, And maybe, let's say, here. Let's give kind of a realistic sort of example. Erase this one. Draw it again. Here. This might be a way you connect rooms. And you can see going north here will connect you to this room. But here you want to go west to get back, right? So we need to somehow define the relationship between those two. We'll just call it label 1 to go with node 1. It's going to be a string in the user types. Pub label 2 string. Now these labels aren't going to be shown to the user directly. It's going to be used for parsing. What the user is going to see is the room description, which should describe all the ways you can go, or maybe you should leave some of them out. Maybe there's some mystery there. Okay, so I think this is basically all we need for our graph, for our edges. This is all the information we need for edges. And then we're going to have the edge direction. Now, this is pretty simple. Edge direction. We're going to have, let's see, bidirectional. In other words, you can go both ways. From 1 only, from 2 only. Something like that. You can go from node 1, from node 2. Something like that. This is basically what I need to be able to what I'm looking for. And now that I'm looking at this type, this is highly specific to my game. So I'm probably not going to find a graph out there that will give me all of this. Now, I probably can get this much for free from some sort of generic graph implementation. This part is going to have to be something that I implement. Basically, what this shows is the arrows, right? If you have these two rooms here, let's say, you can only go this way, right? Or you can only go that way. Or you can go both ways, That's all that is. That's going to be pretty standard for a graph implementation. And I think the real risk I run in terms of using a graph implementation is it's not going to be part of the standard library. Cargo.io? That's not what it's called. Rust packages, crates, I think. Geez, okay. Why am I thinking cargo? I don't know what that's from. The only problem with the graph implementation I find is it's not going to be, it's going to be out of date, and it's not going to be like standardized. So it's going to have a lot of rough edges. So let's sort by recent updates. If it's not been recently updated, I probably don't care. No. See, a lot of the stuff is not even that relevant. All right, well, I feel like we're having better luck the other way. 2 years, 1 year, 3 years, 7 months. SDK for Microsoft Graph. Well, that doesn't help me. Graph processing module for something specific. That probably doesn't help me either. See, this is a plugin for something popular. That's why it was updated recently. Okay. 8 months ago, tool to analyze and manipulate transcript segment graph. What the heck is that? That's cool. I'm interested. A format that combines the benefits of transcript segment data structures with graph-based representations. Transcript segment. What's that all about? Did I misspell it? Segmente. Okay. Interesting. Is this the library I was just looking at? It is not. It's a different one. Okay. But it seems related. TSG CLI seems related. Tool to analyze and manipulate transcript segment graph. It literally does the same thing. Oh, that's funny. Okay. Sure. Oh, building graphs. Hey, there we go. Maybe that's useful. I mean, I need to you build the graph once at the beginning when you start the program, and then you can analyze it and analyze and manipulate. This might be okay, but what's all this extra stuff that I don't care about? What are transcript segments? Segmented transcript data. What the heck is that? Is it something to do with LLMs? Is that really what this is about? Okay. See, this is what I need, right? Edges, nodes, groups, and chains. I just need edges and nodes, really. I probably can make use of those when I'm ready to do more advanced stuff, but we're thinking MVP now. Export graphs to dot format for visualization. This is a big plus because then the person who's making a new story could just get a map of their setup. Right? That's great. Traverse the graph to identify valid transcript paths. Okay, biological validity. Read identity tracking to ensure biological validity. So this is something to do with science. Okay. Genomic coordinates. Okay, this is stuff I don't need. Okay, I know nothing about this stuff. Don't think I need it. But let's try. Let's try to learn more. TSG was modified. Okay, this is modified 8 months ago. Whoops. 8 months ago. TSG was modified even more recently. Let's just check out the documentation. Maybe look at the dependencies. How many dependencies do they have? An optional dependency on TSG core. Okay, well that's reassuring. I just want to see, is this something that is too complicated to use? It probably is. Probably is a bad idea to use it. There's lots of stuff I don't care about. Where's the actual graph? Is that this? Okay, graph section within a TSG file. What's a TSG file? What is a TSG file? Let's see if it brings up biology or not. Nope. Something to do with DNA. I doubt it. How is it used? Interesting. So they've got a standardized format for the specific kind of research. And I don't know how true this is. But I can see if if it's about tumors, I can see why it's abbreviated so often. Because no one likes to talk about that when they're at work. Yeah. Okay. I think this is going to have too much stuff. It's going to be too overloaded with other stuff, I suspect. Oh yeah, it has all the same stuff in it. Okay, well, yeah. Lots of extra stuff, but man, I know that's got to be a robust graphing library, and I'm tempted to try to misuse it for my use case. But, yeah. Graph rewriting language. None of that looks like it's useful to me. It's another robust system that does way more than what I need. Okay. Unfortunately, the concept I'm thinking about is so generic. I don't really want to write my own I really don't want to write my own graphing algorithm because I'm going to suck at that. Like, you know what I mean? Simple graph traversal with visitor 4 years ago. Okay. The reason that this was only edited 4 years ago is because what I'm gathering is when you try to make a generic graph algorithm, yeah, this one's also specific to something as well. When you write a graph algorithm without a use case, it ends up being garbage. That's what I'm gathering. Pathfinding a graph operations. It says work in progress, but it hasn't been updated for 2 years, which means it's not a work in progress. It's abandonware that's broken. Okay, fair enough. I mean, will contain standard pathfinding algorithms. I can't deal with that. I'm not smart enough to deal with that. I can't pick up their pieces and put them together, so. Yeah, so what I'm gathering here is if you're going to write a graph, it needs to be specific to your use case in order to even matter. Arrow native graph processing engine. Let's close things that we're no longer interested in because we have more things to research. This is suspicious. It's not going to be helpful. In-memory graph database. Okay, interesting. Okay, Rust package for the creation, manipulation, and analysis of graphs. That's probably my best lead so far. It's only 3 months ago. Okay. I thought it was made in 2018, but it's just... Okay, got it. It's just a version of Rust it uses. The older the better, from my perspective. I don't care. I don't want my libraries to use a bunch of new features. I want to use new features in my application code, but I want my libraries to be as old as possible. Old and portable. All right. Okay. Creation, manipulation, and analysis of graphs. Okay, what is a graph? We're pointing to... Uh-oh. Vertices connected by edges. Direction? Undirected. Okay, good. They can be directed or undirected. And if they can be directed, they can be unidirectional. Okay, great. T specifies the type to use for node names. A specifies the type to use for node and edge attributes. Okay. Attributes are optional extra data that are associated with a node or an edge. For example, if nodes represent people and T is an I-32 with their employee ID, T being the node type, the node attributes might store their first and last names. Right. Okay, this is what we need. We need something like this. Recently updated. I'm betting it's kind of small. I'm betting. Do they have the code? They do. Let's see how big is their source. Huge! Okay, it's not small. I'm going to work with it anyway because it's the best option I've got, but that's a sign that it might be... That's a sign it might take me... Like, I might spend 10 hours just trying to learn how to use that thing, which I don't want to do. Oh, wow. This is totally related to... What? Middle Earth? Why is it talking about Middle Earth? Oh, okay. It's just using this as an example. Okay. The idea is to create some graph related with the Middle Earth. I mean, I feel like they should describe what kind of graph they're trying to create, what kind of example they're trying to give, rather than describing their domain. I mean, the domain's pretty obvious. We can see Frodo here. We can see Gandalf. I guess if you don't catch the reference to the movie, but if you don't catch the movie reference, you're not going to understand that either. So, or the books. Yeah, I feel like we should describe what we're trying to do, rather than like create some graph, right? Like, well, graph's the part that I don't. Graph is the only part of this I don't understand. That's what the use example is supposed to elucidate. Is what that word means from your perspective. Okay, this has been updated recently, relatively. And it is also big. Okay. So I understand the other one a little bit easier, so I'm going to use it. Arrow Native Graph Analysis Engine. SQL interface. I don't like that. What's ArrowGraph? Arrow Native. What does that mean? What is an Arrow Native Graph implementation? Apache Arrow. Okay, this is not what I wanted. Arrow Graph. Data Fusion. Current prototype. Okay. Yep. Use case. Architecture. I'm confused. I'm not seeing much of a reference to graphs. I think it's mostly about the application it's connecting to. So this is the winner. Graphers. I just realized this is supposed to be GraphRS. Took me a while. All right. Now that's the next thing we need to do. But you know what? I don't think we're... it is kind of important. It is kind of important. I think, though, if I can... I think I want to figure out how to new one of these. If I can figure out how to new one of these quickly, then I will... If I can figure out an easy way to new it... Let's see some examples here. We have our nodes. So we have a vec of nodes. And we have a vec of edges. Okay, weights... I don't need weights. Ooh, you know, I never thought of even if it provides what I want or not. Okay, all items, graph, and edge. Specs. Well, what the heck is that? The graph struct represents a graph of nodes and vertices. Support for directed and unidirected, undirected. Good. Multiple edges between two nodes. Oh, that's cool. Self loops. Yes, that's something. We want all of this. This is all going to enrich our game. All this is going to enrich the storytelling. 2 arguments. Specifies the type to use for node names. Right. Right, we already read this part. Attributes gives us what we need. I'm concerned about weights, though. I should probably just look more into it. Oh, look, we opened Edge preemptively. Okay. We have an edge with a U and a T. Wait, U and V. Oh, U and V are the 2 nodes it connects to. Got it. So in their example that they gave us, in this example, where they talk about T is an employee ID, right? So we're talking about, staff, maybe staff at some business, right? T is an employee ID, or the node is an employee ID, and then the attributes might store the first and last names. Okay, so in this case, this would be the employee ID for the 2 employees that are connected, and then this is attributes of the edge, not attributes of the node itself, not attributes of the employee, attributes of the relationship. Okay, and attributes are optional, sure. Now, in my case, attributes aren't optional. That's a little bit frustrating that I can't make it required, but also weight. The weight is going to be the same for everything. For weighted graphs, this should be a real number. For unweighted graphs, this should be nan. Really? Did they do something special with nan? If I weight them all as 1, is that bad? If I weight them all as 0, is that bad? Unweighted. It's only referenced in one place. Okay. New. A new edge from these 2. Okay. Ordered. Returns VU if U is greater than V. Huh? I am not understanding that. I don't think I care. Reversed with weight. Creates a UV edge with a specified weight. What does it do with weights? Okay. I think for my purposes, at this juncture, the only thing that matters is the author has done something to support unweighted graphs. That's all that matters. I don't need to know the details. I just need to know that support is available. So, and I need to know how to define attributes. Now, I get to completely define the attribute type. Unfortunately, it's going to be optional. I have to figure out how to add attributes at some point in the future. But that's okay. Man, I wish it was like new with attributes. You know, we have with weight. I don't care about that. But why has it got arc? This is so weird. Why in the world does it have an arc? What? Oh, maybe with a weighted graph they want to do maybe they want to do concurrency? I don't need to know. I don't need to know. But the point is, we can use this graph for RS to support us. So let's write that down before we forget. Yeah, we don't need to define that yet. At some point, we need to hydrate graph via the graph RS library from story description. Okay, great. All right. I might actually have AI create a parser for me at some point. I think I'll use JSON format in the beginning, but I think a parser is something AI could do, and all I have to do is read through the unit tests and make sure the unit tests cover all the cases I care about, and then just tell it keep going until the unit tests succeed. I think that's a way I could use AI, leverage AI, and have it be less work than doing it myself. Because parsing is something where it's relatively easy to test it. Relatively easy, because it's text manipulation, ultimately. It's like, it's interpreting text correctly, right? So that's, yeah. Anyway, the point is, we can do this. We can do this. So, in our program, here we go. You can get rid of that. In our program, this is going to be an edge description. Right? And I think, okay, let's go back to graph. How do we new it? Come on. Okay, that was weird. We have our nodes and our edges, and you can see we create a graph new from nodes and edges. Nodes, edges, specs. Okay, great. Now what's a spec about? Directed. Okay, that kind of stuff. This seems, oh, come on, I wanted to open a new tab. There we go. This seems straightforward, right? What we're going to do, instead of trying to store the graph somewhere, mainly because I don't want to learn the API yet, I'm going to store the nodes, or I'm going to store the names of the nodes, and I'm going to store the edge values. I want to store the attributes I need for the edges. And then I'm going to store the attributes and the appropriate association. Whoa. Yeah, you see, here we have the label in1 and the label in1 to in2. Like this is an edge from in1 to in2. I'm going to store all the relevant information and then use that to hydrate the edges. Use that to basically, I'm going to do this step when the program loads. I'm not going to store this in my data structures directly here that I have here. Although the graph is going to exist in the world, it's not going to exist in the AST. Okay, it's getting complicated. Basically, I'm trying to avoid learning all of this. I'm going to quickly look at this, though. Directed, true or false. Dedupe strategy, we're not going to worry about that. Missing node strategy, we're not going to worry about that. Ultimately, if there's a missing node in someone's story, it's a programmer error. Like, the person who made the story made a mistake. They can fix it. They can test it. I don't care. Like, if there's an easy way for me to test those things for them, great. But if not, it's not my problem. Yeah. Multi-edges, yes. Self-loops, yes. Okay, so self-loops false strategy. Interesting. Okay, so it looks like it supports what we need. I'm interested in this. I want to see how it affects my loops, but to be honest with you, I could have a perfectly functional game even if I didn't allow a room to loop back to itself. So even if I say self-loops false, that's the worst case scenario, right? Because this is going to have some impact on how self-loops work. But the worst case scenario is I just turn them off completely, so I don't have to research that now. Okay, this is all stuff we're going to look at later. Yeah, we're going to get right into it. Yeah, let's get back to this. Uh-huh. Uh-huh. There we go. Okay. Okay, we don't need this right now. All I really need to know is that this is going to be, it's going to be effective, right? And for now, we're going to have that like that. It's fine. Whatever. Node 1 is going to be the room ID. Room ID. Okay. Okay. I don't know if these are actually going to be... Yeah, these are going to be edge attributes. Okay. Now, I noticed in that example they gave, they did not define edge direction, and they didn't show how to add labels, or how to add attributes, rather. So I think we're done at this point. Yes. We don't need the chat open. Okay, great. I think we defined it. Now we just need a format. Yeah. Right. Okay, so... add edge description type and tweak existing. We can hydrate a graph from the edge descriptions from a list of edge descriptions and a list of rooms. The list of rooms. Whoops. We'll research that later. And now this is enough. Okay. Okay. I'm going to take a short break and come back. What I'm going to do is find some sort of, yeah, good stuff on YouTube to listen to. I have a bit of an intermission. I could quit for the day, but I think it'll be fun to keep going. I think I just want to keep pushing through. Right then. Whoa! And then, hang on a sec. Uh-huh. Let's give you 10 hours of this, and then I'll come back. How's that sound? I'm kidding. However, let's make sure it's on there. Alright, I'll return in a little bit. Y'all enjoy this this video, which is Creative Commons, I believe. I believe I'm allowed to share this. So anyway, enjoy this peaceful lake. All right, I'm back. Hope you all enjoyed this little interlude. Let me check out the music. I actually haven't had my headphones on. Let me hear it. Actually, it sounds nice. Maybe we'll listen for a little while longer. All right. Hopefully, I don't get a copyright strike. I'm really hoping so. Anyway. You know what? I'll be honest. I'm hesitant to leave it running because I might have to delete the sound of me talking. I've had that happen before, so I think I'm gonna experiment. I'll leave this in the video, and if I don't get a copyright strike, then I'm gonna feel free to do it again. All right. So I'll feel more. This is an experiment, so maybe we'll have music later on. Okay. Now then, I didn't even commit this. Wow, I left in a hurry. Okay, hydrate a graph from the list of edge descriptions, list of rooms. We'll research that later. For now, this is enough. Right. What I realized was, in my world, I don't want to put my edge descriptions. Frankly speaking, I don't even want a vec of rooms. What I want to do is put my graph here. But at this point, I understand conceptually what my world looks like. I don't need to tweak the data structure any further at the moment. But I'm also realizing what I definitely want at this point, since AI is available to me, I think I should take advantage of it. I need a separate data structure for parsing into a world. Like, for example, excuse me. When a game author creates a game file, they're going to have some edge descriptions in it. But an edge description is not an object within the game, right? In the game, you have an edge. It's going to be part of the graph. It's going to be one cohesive, holistic thing. But in the description of the game, in the file the game is stored in, we have to describe the edges in some way, right? And then once they're described, they have to be manifested or hydrated back to their true forms. And so this really doesn't belong with the other files here. It's just here kind of to help me remember what should be happening when I get my graph in place. We're not going to do any more. We're not going to do any more with this. Yeah. So we're not going to do more at the moment. I did forget to check. You know, I forgot to check. Oh, wait. Oh, I just realized something. An edge can be, if every edge is one-dimensional, like, let's say, okay, I wanted to have bidirectional edges. But if every edge is unidirectional, here, let's just call this from node, to node. We can simplify this. We get rid of this. Path, label. We'll just call it label. We can simplify this type. And then, if we want the user to travel between both directions, we have to specify. We have to go, we have to specify two edges, one in each direction. It just dawned on me, this is way easier than trying to, this is way easier to describe than trying to store two labels. Yeah, this is much easier to work with, programmatically speaking. It's going to be a bummer for the end user, and we just added those. We don't need to, like, make a new, Yeah, perfect. And we'll have an edge in both directions if we want to have... Okay. Right. Yeah, I don't guess I need to put that here. Yeah, a bidirectional edge is just a bundle of two edges, right? One goes one way, one goes the other way, right? So this is enough. We don't need more than that. This is kind of cool. Okay. So then our from node can have a list of edge descriptions. Oh. Yeah. Okay. Let's have a room description. Okay. What's the opposite of hydrate? Dehydrate? But in terms of the food analogy, let's get back to the food analogy. In terms of food, to hydrate a food, presumably a previously dehydrated food, is to add water to it. Okay. What is a synonyms for dehydrate? Dehydrated, as in the phrase dehydrated food. I guess I could say dry. Jerky. I could just call it jerky. No one's going to know what that means. It's going to sound a little bit sus. More synonyms. I love how dehydrated is one of the synonyms for dehydrated. Vacuum dried, sun dried, air dried, power dried, freeze dried, removed moisture. That's not even an adjective. Dewatered. Okay. I don't want to use the word description here because description's here, right? But I do want to define a parse model. I think parsing is our next step. Hang on. Let's celebrate a minute. We got this part done! Yay! A few more tweaks to it, but yay! Let's go ahead and put that here just so we can celebrate. Define world and types. Done! Yay! We need some fireworks or something. Alright, I need to get fireworks animation for that. Okay, great. Now moving on. Step 2 is import and export. I'm immediately thinking about parsing. I might even be able to get AI to do a custom format for me, but we are going to... I think we're going to stick with JSON for now, just to get moving forward and maybe have AI work on something else. Something a little more user-friendly for the authors of the games. And okay, so we want an edge description, we want a room description as well. We're just going to do this. Okay, so we have the room itself. Now, it dawns on me that an edge description doesn't need the from node. It just needs the to node, because it's going to live inside of a room. Okay, what just happened here? I think my mind went on a vacation while I was typing. Okay, we'll get rid of the from node. Yes. Edges. Vec of edge description. Yes, there we go. I'm kind of regretting I'm kind of regretting that I amended that commit at this point. Okay. Simplify edge type. Edge description. In terms of parsing the story file, or files, we don't need to... We can treat edges as depending on one of the rooms it connects. One of the nodes, rooms it connects. Paths. We can call it hallways, maybe. We can treat edges as depending on one of the rooms it connects. That allows us to simplify the type. So each room will describe the edges which originate from it. Each room description which will describe the edges which originate from it. There we go. You know what, though? I realized something. I think I don't need that complicated graphing library at all. I don't think I need a list of rooms either. Those could be useful, though. I don't. Yeah, we're gonna have a vec of rooms. Okay. We're gonna redo this. We're gonna avoid the graphing API for now. We're just gonna, we're gonna merge this all together. Ready for this? Edges. State. I don't know where to put it. Inventory features. Pub edges. There we go. Edge descriptions. We want to call it something else. Pass. From. Graph edges? I don't know. We need to somehow marry the concept of a room and a node. Exits, maybe. Yes. Yeah. We call the edge descriptions room connections. We'll call this toRoom. And I don't think we need to know which, north, south, make it lowercase, up, downstairs. There we go. Those are some examples. It helps if I can spell. Yes. Okay, great. Great. Okay. One thing this doesn't allow us to do, as far as I know, or at least at the moment, we're going to call this an edge. Probably we should call it path. Between rooms. Delete this. We don't need that anymore. Man, we're simplifying so much. This is great. We're simplifying our graph traversal. And yeah, it's immediately obvious to me how this is going to work. Basically, when you're in a room, so basically, when you load a new world and you put the player in a room, the world, like, the game's going to load some room, going to pick a room at random maybe, just pick a room to put the player in. It's probably going to be a specific starting room. Put the player in a room. Then the player is going to look at the exits and pick one. Take one path. And then it'll tell which, and so let's say the user wants to go north, or the player wants to go north. The game will open the north path, if it exists, and say, okay, if you want to go north, it's this room, and gets it by ID. right? And so the label is north, to room is ID, da-da-da-da-da. Honestly, exits could be a hash map. Oh, shoot. Path can be simplified even further. Pub type path equals exit. Room exit equals hash map from ID to from string to ID. Da-da. Okay, now does this documentation show up? It does. Great. Mapping from the exit label, north, south, upstairs, down, etc., to the room ID of the room it connects to. Right. And what's interesting about this, edges or paths, like hallways between rooms, or like connections, exits from one room to another, whatever you want to call it, they seemed really complicated when I thought about the idea of, normally if you connect two rooms together, by default, the user can go both ways. The user starts in room A, let's go back to our graph. Let me find our graph. Oh, here it is. Okay. Okay. The user's in room A. They go south. Now they're in room B. Okay, they're in room B. They can go back to room A. But some of them are going to be unidirectional, right? When I think of it that way, it gets really complicated. But a really nice simplifying assumption, or it's not even an assumption. It's just a nice way of thinking about it is, oh, wow, that's not what I wanted from life. Hang on. Undo, and then, okay, you're in room A, and you got your room A and room B. Wow, I did better the first time. So we can simplify it by just saying, hey, there's a path from room A to room B. And you can only take that path in one direction. There may be a path from room B to room A, but you don't know. You're in room A. You're looking at, you're thinking about going to room B. You don't know where room B is, first of all. You don't know anything about it. You just see the exit. And you don't know if you can get back or not. So I like this. Instead of representing the edge as this complex type that can have different states, no, we just have two different edges. And look how much it's simplified. We just have a label describing which path we're taking, and an ID describing which room we end up in. Extremely simple. Undo. I do want to call these paths. I think path is better than exit. I'm going to call it exits here. Exit from the room is going to be a path. Right. Well, we don't need two of them. You just need the one. This is really nice. This is really elegant. I like this. Now, we may at some point want to revisit the idea of a graphing library, but I don't think we need it. We're going to do something very simple, really simple, stupid simple graph traversal. I think we're going to be fine. Okay, so one thing we're going to need here, before we do anything else, let's save this. Simplify room traversal and paths. If we consider edges, paths, as always unidirectional, and then allow multiple edges between two nodes, rooms, it vastly simplifies the edge type, the edge description. All we need is a label for the edge and the ID of the room node we're connecting to. By storing this in the node, in the from node, we implicitly where we're coming from. Perfect. Now, pub starting room is going to be an ID. Okay. Player is going to have a location. It's just going to be a room ID. I'm considering making a separate type alias for room ID just to make it easier to understand. I think I should. Pub type room ID equals ID. Last time I took my time doing that for the chess project, and I regretted waiting. Room ID. Okay, player ID, room ID. It just makes it easier to understand. We're going to call it room ID there. This is a room ID as well. We're using room ID so much, it just really helps. Keep it simple. Inventory, nope. Nope, maybe we should have item ID there, but okay, none of that's going to be relevant. Now what about over here, interactions? Interaction ID? No, we don't have room ID. Okay, great. The only way I could see room ID coming into play for interactions is if we want to at some point store the state for rooms and the state for the world in the same location. But we're not doing that for now. We're just going to keep it localized right here, and just the room ID is implicit because the state's contained inside the room. It's contextual. Right. Okay, great. Nope. Split. Nope. Yes, yes, yes. DX. Make room. Oopsie daisy. Room ID alias. Type alias. Okay. Player's going to have a starting location. Yeah, they're going to have a location they're currently in. And there's a starting room for the world. Right. Let's just say starting location. We'll call it spawn. Yeah, spawn. The world spawn. Yeah, this place where players spawn. Room where players spawn. Now, eventually I want to be able to have multiple spawn rooms and like some algorithm for choosing between. Maybe it needs to be round robin or distributed or something. But for now, I think a single spawn room is fine. We'll figure out the rest later. Now, okay. Add player location. This is beautiful. Okay, great. Now I was going through all this big thing about how we were going to instantiate a graph. No graph. I don't think we'll end up ever using the graphing library. I went through this whole spiel about hydrating and this and that, but now we're not going to hydrate because we're just going to directly use these types. Because they're dead simple, we don't need complicated. Okay, so, should have done this to begin with. But I was just struggling because for me, I was thinking, well, you can't have a list of exits. You can't have a list of edges because the edge connects two rooms. The edge is separate from the two rooms, right? But now it's not, right? It's an exit from a room. Maybe I should rename it exit. Maybe that's what I should call it. Yeah. Honestly? Yeah. That's a really good name for it. I'm going to keep calling it path for now. Because exits, I don't know. I still want to keep some kind of connection to the idea of a graph somewhere in here. Path is kind of like another name for edge, I guess. Anyway. So here we go. All right, now this is getting to the exciting part. Right. Now that we have this, serializing should be pretty easy, but I don't know if I want to do it the dumb way or not. In other words, I don't know if I want to serialize, like in my file type. I don't know if I want to make it convenient for the user, or if I just and then write a parser for it or whatever, or if I just want to quickly get it done. I think I'll try doing a custom one and having AI translate for me. I think I'm going to change the order of these two. Boom. I think this is going to help. Oops, Control Z. Never mind. Never mind. I guess I'll put a period there. Come on now. Here we go. Never mind. We'll implement graphs directly. And this right here, folks, this right here is the reason, I think, and this right here is the reason the graphs end up being implementation specific, because this is all I need. Very, very little that I need. I don't need a heavyweight graph implementation, and probably it would have been more work than not. Just using that thing would have been more work than not using it, I think. This is probably why there aren't that many. Yeah. I guess if I wanted to export to .viz, I might be looking for a solution then, but yeah. Right, so what we're going to do is first create a game. And let's look at this game together. It's going to be, let's figure out what we want from our game. Let's go ahead, even though we're going to draw something similar, we're going to start over here. We're going to have 3 rooms. Yes. And then there's going to be A, B, C. This is not going to be a fun game, right? We're going to have some connection points. A goes to B. B goes to C. C goes to A. It's not going to be a fun game. Then we're going to put an object inside of A, stapler. And a different object inside of B. Actually, I think inside of B, what we're going to do is we're going to put an interaction point. We're going to type it out instead of trying to draw it again. Switch. We're going to put a switch in there that you can flick. And then the switch is going to turn something... well, the switch is going to turn on the light in the room. No. Yeah, okay. Yeah. The switch is going to turn on the light in the room. The switch and the light. Right. And then, I just wanted to move that one thing. I didn't want to move everything. Okay, well, that's sad. Anyway, then here we're going to have a switch. Or we're going to have a button. What this button is going to do is it's going to dispense a stapler, right? In fact, let's just, erase the button. Button stapler dispenser. There we go. So basically, it will dispense a new stapler. Let's see, yeah, let's put it there and there. Okay, well, you get the idea. We're just going to move this over here, actually. This is going to be easier. And put an arrow in or something. I don't know. Right here is our stapler dispenser. Right. And we have a light. And we have a switch. All right. So we're just going to create a stapler out of whole cloth in Room A. The idea is this stapler dispenser is going to dispense staples into Room A. It's going to be a global state modification. And this is going to be a local state modification. So, local state, switch controls light. Okay. Whoa. Global state. Button causes stapler to be dispensed in Room A. I just realized, though, that the game engine we just defined doesn't support this. Because we don't have any way for an interaction to create a side effect. We can change a value, but we can't just create an item. Huh. Well, we could make a new interaction type. Item creator. And then we have item ID. See, this is creating an existing item, though. That's fine, I think. And then we'll just call it item. Oops. Item. Room. Room ID. Okay. This is not a well thought out feature, though. We'll have to change this. It's going to have to be changed in some way. Item duplicator. That's really what's going on here, is we're duplicating the items. Now, what I've just realized... Let's look at our items. Yeah, I just realized a problem. We need a list of items, a global list of items. Pub items. Vec item. Okay, let's do it like that. Okay. Yeah, well, whatever. And then everywhere we use item other than here is wrong. Okay, this would be item ID. I think this is the only place. Wait a minute. An inventory was supposed to be a hash map from IDs to items, from IDs. So basically, it's a list. Oh boy. Yeah, but we can't duplicate items. I think this should be. Huh. Man, that really frustrates me. I have this implementation here that's not going to work anymore. It shouldn't be a hash map. I think what this shows me is I implemented this too early. Way too early. It was good to get concrete. It was very helpful. But this doesn't work. Also, I feel like I need an item ID. I'm getting confused. Pub type item ID equals ID. Why not alphabetize while we can? Come on. Save. There we go. ID. Okay. Item ID. Item ID. Item ID. Item ID. We'll do that in the commented out code too. Item ID. For some reason, something else happened. Great. Now we'll go back here, and I think it's only item ID. That's going to need to be imported. Great. Okay, great. I love how I thought I was coming up with a simple example that was just going to completely, just going to be super simple. And already, just based on this simple diagram, I already need to make a change to the system to support it. It's a good change, though. It's a good change. We want to give story authors the flexibility to do things like this. Okay. I want to name it something else. I don't want to call it, I do not want to call this item duplicator. Do I? Instantiate's a really good word for it, but I don't want to get I don't want to use super technical programming language to describe it. Synonyms for instantiate. Manifest. I like that. Manifest item. Realize. More synonyms. Actualize, materialize. Install. Oh. I could poof something into existence. Let's just keep it super simple. Item creator. It's called that. Tweak to right, hang on. Interaction type. Allow creating items. To support this, we create an item in a room by referencing an item ID. We create an item. To support this, we need to separate the definition. Oh wow. Definition of an item. Instead of separate, we're going to say distinguish. Distinguish the definition of an item from its instantiation. Yes. Therefore, additionally, we don't want the definition of an item like this. an item definition is oh boy, instance is the wrong word to use here. Is an item object. An instance is an item ID, which refers to the definition. Perhaps later, instances may have what do you call it? Properties. Let's just call it properties. Like damage or health. Later. Right now, that's not going to be a thing. Okay. Great. So, keep a global list of items in the world. I just realized that we should be using hash maps here. Keep a global list of items in the world. Refer to them by item ID everywhere else. Make item ID alias. Add create item creator interaction type. Okay. And something else I just realized, these should probably all be hash maps. From ID to player. Room ID. Why is that not working? A struct with a similar... Oh, I just misspelled hash map. Got it. World. Use lookup tables instead of lists. Yeah, because we need to look up things by their ID probably frequently. For players, less so, but we can still create a list if we want to. We can just do players.values or whatever. That's completely fine. In fact, I wonder if we should even bother to store IDs inside the object itself. That's kind of redundant information, to be quite honest with you. But we're going to, because we like being duplicitous. Well, it can be nice. Okay. I don't think there's anything else we need to break in order to move forward. Now, the next thing we want to do is make our first game, or our first, not under source. A new folder. We'll just call it, nope, not under source, actually. New folder, games. Okay. New file. What are we going to call this game? We're just going to give it a random name. Cool names for an RPG. Let's see what comes up. Eclipse of Destiny, Shattered Realms. That probably is already a game, honestly. Like, I can't trust this without giving it more. I need to give it more parameters in order to trust it. I don't want to copy something else. Let's just call it. What do we call this? No, it's not. Okay, it's not always on top anymore. Interesting. Demo. I'm going to have multiple demos, but we're just calling it 3-Room Circus. Yes, that's it. 3-Room Circus. It's a pun. It's clever enough to satisfy me. .json. Alrighty. Now, we get rid of the second tab, which we haven't been using. Okay. Zoom out a little bit and then pan around. Zoom in a little bit, pan around. Okay, this is better. Like so. Great. So I'm just going to start describing things, and it's going to be wrong, and I have to start over. Well, first of all, we have our world, right? Starting room, right, is going to be 0. Right. Yeah, let's just go through and define everything. Players, we're not defining. Rooms, we're going to define. Items, we're going to define. Okay. Let's start with items. Items. Label. Whoa, okay. Item. ID and description. You know what? I just realized an item needs a label too, so we're just going to call this pup. Wait. Oh, funny me. Okay, label and description. I think having these have the same name is probably not helpful. I need to rename this probably at some point. I don't know, something. One of these two. Stapler. I just realized that description needs to be optional. Because if it's missing, if the description is missing, the description field, we'll just call it an ordinary stapler. You know, an ordinary blah. So we're going to have a default description. In fact, let's implement that now. Pub function default description self let's wait for the error message before we do anything. Format an ordinary self.label. Now this is an error because we don't have the return type defined. Found string. Okay, great. We're going to call it a string. Okay, perfect. Now that's a change we can commit. That's a really good isolated change. Make description optional. Okay. Labels a stapler. There's not going to be a description. It doesn't need one. So, bam. But, oh, we need an ID for the thing. I think that's important. Items is going to be a list. ID 0. Man, I really wish it would let me add parens at the end. I don't like that formatting at all. I'll live with it for now. It's like taking way too much horizontal space. Okay. Rooms, I think, is next. Let's go back and look at our world. We have items defined. We have our spawn. We have our state, which is implicitly going to be empty at the beginning. It's always empty. Although I suppose, no, the user is going to specify defaults over in the other area. If they want to specify a default, it's going to be here, right? we want to have one way to do things. We don't want to have more than one way to do things. So, where is it? Yeah, default state, right there. That's where that's defined. We don't want a default state up here in the world. Okay. So, we don't need this. Why is it open? Okay. Types. Items. State is going to be created. Players is going to be based on who joins, which is going to be just one player for now. This is going to... Like, the list of players is not an attribute of the story, obviously. It's who comes to play the story. It's a side effect of the story in some sense. Okay, we have our rooms. We have our spawn point. Oh yeah, it's called spawn point. Spawn. Right. And then we just need to define our rooms. List of rooms. It's going to be a weird format I don't like. We'll just live with it. Okay. Now. Room. This is going to be an interesting one. You know what I just realized? Hey. There we go. That's nice. Okay. This is going to be ID 0. We're going to give a label directly. Maybe we shouldn't because, anyway, whatever. We're going to give a label directly. A large room, a large square room with a square room with a large A painted on its concrete floor. There, something like that. Now, after that, we're going to have some exits. We're going to do those later. Inventory features. Yep, just inventory. And then we need to do that. Okay, we're going to do exits. And we just need, what was it? Quite honestly, this doesn't have to be... Yeah, okay, so let's do it this way. Huh. Actually, no. Exits could be a hash map. Vec path. What's a path? Oh, I did this wrong. Oh, oopsie, undo. Room exits. I did this wrong. There we go. Path doesn't exist. Bug room. Fix exits type. There we go. Yeah, when I called it a path, I confused myself. That's why I had to rename it. Okay. Now, exits right, and I realized it once I got down here. So we're going to have a south exit. Okay. Concrete floor. There's an exit to the south. There we go. South is going to be... It's going to go to room 1. That's the only exit. Okay. I'm kind of gotten lost. Okay, we have our exits. You know what? Exits can go before inventory because, quite honestly, it's probably going to be simpler. ID description exits inventory features. There are no features. We're going to leave that off. So it just comes down to inventory at this point. I think I want to go ahead and describe the inventory as we go. So let's jump to that. Nope. Inventory. It's just going to have a stapler, right? So inventory is basically just a list of item IDs. Item 0, we have one. Actually, our max capacity is important for this room. Max capacity. Could just call it capacity, but we're not going to do that for now. Max capacity, let's say 10. And then storage. Maybe I should call it items. Items. 0. There's one stapler. Alright. The user will think that the inventory or the stapler is significant at first, but they'll realize later, well, it's just a gimmick. Okay, I guess they'll think the game is important in the beginning, and then they'll realize it's dumb. That's another way to phrase it. Anyway, it isn't supposed to be it's not supposed to be an amazing game. We're supposed to test the idea out. First of all, this is very verbose and hard. Like, even though I'm trying to make abbreviations and shortcuts, this is really complicated. All right, label for room B is, we're going to copy the description, the inner quote, boom. Except instead of an A, there's a B. And there's an exit to the east. Yes. Exits. East. It leads to room 2. Okay. And then inventory. Nothing. It's going to be blank. We're going to leave that off. However, it is going to have interactions. Is that what they're called? Uh-oh, that didn't help me any. Room. Room, spell it right. Oh, nope. Here we go. Features. You know what? I'm going to call it interactions, because I'm getting confused at this point. And apparently it's going to be a VEC, although I'm starting to disbelieve that. Okay, we have a list of... You know what? It could be... We could do a hash map from ID, but I'm not seeing how we're actually using the ID. This is a hash map. Inventory is ultimately a VEC, I think. And inventory has to be a VEC. It can't be a hash map because we can have multiple of each item. Maybe, you know what? Inventory could be a hash map. Oh, I realized. Inventory could be a hash map from ID to count. Yeah, and we might still end up using this. Comma there. Storage, hash map, item ID count, question mark. Maybe we should do that instead. Regardless, we should have a comma there. Okay. Now. Let's not change things right now because I'm getting confused already. We have an interaction. ID 0. Right, this is going to be the light. Yes, we're going to try the light first. Now, again, this is a local interaction. Okay, description. Now, this is the user description. Now, this is what the user sees. Oh, wait, they shouldn't see a description. They should see a label, shouldn't they? Well, oh, okay, we'll figure that out after the story is written. Light. I type is going to be type observer. Mapping. I need a better name for this. Clearly, iType is not the right name for what I'm doing right here. Mapping. And it's going to be a hash map. One thing I'm missing here is a variable label. I feel like it should come before the iType, honestly. In terms of just making it easier for me to understand when I'm reading through this. Oops. Okay, description. Variable label. Maybe I should just call it interaction label instead. Oh, looky there, we have a label and description all of a sudden. Okay, I don't know why those merged together. Label, light. We have a, what's with this description? Yeah. I guess the description is for when they look at it more deeply, like examine description. Maybe that's what it's called. Yeah. Yeah. Just a normal light. An incandescent light bulb. The filament looks undamaged. This is kind of a hint. Maybe you should try turning the light on. Oh, I forgot! There's supposed to be a light in room A. Okay, we'll have to get back to that and do that. Okay, let's put a light here. And text. Light controlled by C. Now, the name of the variable. Oh, yeah. Oh, that's right. This is a variable label. Oh, you're right. It's not the item label. Okay, so maybe we do call it state label. We do need to call it variable label so I don't get confused. Light B. Right. Okay. So this interaction controls a variable in the room. Locality. Where? No. Okay, that doesn't work. Locality. Room. World. There we go. We could call it state interaction, maybe. Interactions. locality. It's going to be room. Right. This is too complicated to understand for someone other than the person who wrote, like, other than me. And by me, I mean the person who has just written this and just looked at this type. Someone just looking at this file is not going to understand what this all means. So I need to come up with a better way to describe it, and maybe even change my data structure to match some other way of looking at things that's easier to understand. Or at least change the format of the file. There's definitely some work to be done here. Default state. Excuse me. There has to be a default state because we can't map from no state to some value, right? Our mappings down here are not from optional value to optional value or from optional value to string. It'd be easy to support that, but I'm not going to. You know, we're not going to do that at the moment. Default state is 0. Okay. Now this is the light bulb. It's an observer. Yeah, that's the only thing left to define. And the observation is, we just saw it, a mapping. Okay, when it's 0, the light is off. Really? You can't. Interesting. I didn't realize you couldn't have numbers as a property in JSON. Okay, cool. The light is glowing brightly. The light is radiating a gentle warm. The bulb is radiating a warm light throughout the room. There's a better way to say that, a more romantic way to say it, but whatever. Oh my goodness, look at all. Yeah, this is why I didn't want to have everything on its own separate line. It just makes it so much harder to read and understand. Because these could, yeah, these could be combined, these two, and those two could probably be, anyway, whatever. It's irrelevant. Okay, now. Okay. Right, well now we just need to get back. This is room B. Let's go back to rooms. Interaction state. We do have room state, but it's not something that's defined in this file. The defaults are defined here. Alright, but we have more than one interaction. We have a second one to define. ID 1. Description. A switch. A light switch. On the east wall. Variable label. It helps if you can spell label correctly, doesn't it? Label. I was looking at that thinking something's wrong. Something's wrong. Now we want to make sure to use the same label. That's significant. And one problem with this file format is it hides that information. We need a much shorter way to describe it. But we'll start from here. Okay, so locality. Room. Now these two define the label, right? Because it could be referring to a global. Default state is 0. I type. I honestly want to make the observation like, gosh. I kind of want to make the observation be part of the interaction instead of the interaction type, and make it optional or something like that. I don't know, it's kind of necessary for, it can be necessary for semantic reasons, like if you can't see the light bulb, then I don't know, it could be part of the story to not know. Anyway, type is operator. Okay. Whoa. Not what we wanted from life. And then mapping from 0 to 1. From 1 to 0. Okay. We're already seeing the limits of the JSON format here. I think we're done with that. Oh my goodness. This is interactions. This is room B. Oh my goodness, wow. Look how much was there. Can we maybe take this and hide it? Oh yeah, great. Let's hide the inventory here. Great. Okay, ID 2. You know what's going to help a lot? Well, if we call this room ID, it's going to actually be very helpful. Just to help us keep things sorted. Oh my goodness. Label. That's not label. I get my hands back on the home row here. A, C. There's an exit to the west. All right, now we don't, what I realized about this game, we don't need it to be surprising in any way. We needed to test the functionality. So I think I'm going to literally describe everything. I think I'm going to describe everything in detail so that, yeah, so that it's easy to understand. I'm not trying to be too clever, or, yeah. I'm not trying to tell a compelling story. I'm trying to test functionality. Yeah, there's a more compelling way to say it. We have a west exit, an exit labeled west, and it goes back to room 0. Wait, why are we using... Yeah, that doesn't make any sense. 2. I don't know why I use quotes there. 0, 1, 2. Okay. Now after exits comes interactions. Fortunately, I only need to copy one of these. I can get rid of the... Oh, gosh. I said fortunately as if I could easily tell what was going on here. Okay, we need to copy this right here. ID 0. Something's wrong. There would be the problem. Description. A button labeled stapler dispenser. Okay. Wow, can I even spell the word variable? We need to use a different word than variable because I don't want this to be programmer friendly necessarily. I want this to be like author friendly. So variable is probably the wrong word to use. But it really helps me with coding it to understand what the heck I'm doing, so we leave it for now. Leave it for now. ID, description, variable, label. I'm not going to try to spell it again. We're going to call this light A. And then this one has to be, the locality has to be, wow, we're right at the top line there. Locality has to be world, which is global. Default state is off. Well, wait, state doesn't change. Okay, so we ignore that variable then for this. I'm not going to change anything right now. iType. Okay. I think we're kind of seeing the limits of this notation. Is what we're seeing here. Okay, so type item creator, right? iType item creator. Say hello to the dogs in the neighborhood. We need an item. Yeah, it's not a mapping in this case. Item is going to have an ID of 0, I think. There's only one item in the entire game, which is a stapler. And then room is going to be room 0, room A. We're going to put a new stapler in room A. Oh, it's not a light. Right, it's not a light. Okay, we can ignore that. We can't delete things over here in this. Okay. This default state and this default state and the variable name, none of that makes any sense for this iType. So we need to rework our type quite a bit. In A. Yeah, these three things don't matter at all. Because there's no variable. Okay. Okay, item ID, room ID. Great. And there's no interaction point in A because we're not adding the light. Yeah. Okay. This is a good first step. A good first step. Now let's go ahead . Hang on. Games. What changes did we make here? Not that many. Okay, great. Wait a minute. We didn't finish our last commit, did we? Well, we must have finished it somewhere. No, I don't know what was going on there, but anyway. DW. That's what we want right there. Add a add a game, add a sample game. Add a game. 3-room circus. And update types. Work better. As we to spot check our game types. Spot check QA. As we build up the game, built, discovered several. Where's in the? Yeah. I discovered several errors in the inaccuracies in the game types. In other words, they weren't mapping to the problem domain as well as I had thought. I'm not going to describe it any more than that. I am Yeah. Okay. This has been a great stream. It's we got a lot done. Oh my goodness. I've been on the stream for 3 hours now. Wow. Okay. This is a good stopping point, I think. When we come back, I'm going to make some changes here to like make this a lot less ridiculous. So that's going to be a to-do item. I feel like, do we need any of this? I'm not going to delete it now. I think I'm too tired to make a responsible decision about deleting that. So for now, we're going to have our to-dos. You know what? There. We're going to make to-dos right here. Do-do. Do-do-do-do-do. Rework interactions to share a struct between observers and operators. The variable and state mess doesn't make sense for item creator. Okay. Great. What else? The very next thing I want to do after that is ask AI to implement implement a parser. Okay. And then I guess I'll just write tests as well. Okay. Ask AI to write unit tests, question mark? I don't know, it might be too complicated, but anyway. The parser will probably be using, what is it called? I don't remember. The normal JSON parsing framework for Rust. I'm thinking AESIN, but that's more Haskell land, so I'm too tired to think. It's a good time to stop. All right, I hope you all enjoyed this. It was a lot to get through, but, you know, I guess you guys can watch it. You don't have to watch it in one sitting. But yeah, we got through a lot here, and I feel like we really have a good handle on what's going on in our world. And I feel like we are so close to having a playable game at this point. When I'm looking through this and thinking through it as I'm typing, like there's not a whole lot of nuts and bolts to this that have to be done to get this working. So I feel like what we've done over the last 2 sessions, and this is my prediction, by the way, I could be wrong, but I think what we've done is we've successfully defined a world and a system where it's very easy for the author to express a story, to express a game that they want, and it's very easy for the engine to create that world and share it with the users. I feel like we're really close to being able to do number 4, at least for our 3-room circus, and that'll meet our criteria, right? At that point, we've got our MVP. That's our dead simple MVP. Then we kind of figure out where we're going to go from there. Honestly, the first thing I kind of want to do, even though AI is kind of exciting, the first thing I'm really excited about is increasing the kinds of interactions we can do. I'm just waiting to be able to get in here and do more, but I don't want to mess with this too much. In fact, I kind of want to set a rule for myself not to do anything that's not to add anything that isn't needed for this story. Keep ourselves focused, right? And then, like, get a playable game. Be able to go through this and play the game. And then, we're in a good spot at that point. I really need to rethink the interaction, though. Like, I need to think about the UX for this. One thing I'm not clear on is this description field. What does it even mean? You know, and like, don't I need some sort of label like light switch that the user can see? Maybe I need to pull in. Oh, I do have the description type. I see it. So I've got label and variable label. Oh. So that's an oversight. Okay. I can't name this description and also have a description field inside of it. So I need to figure out how. That's something I need to do. Work out the ambiguity between description and description. I'm getting confused. I probably shouldn't use that word anywhere. Anywhere. I just confused myself. Identity. From a UX perspective, this contains the identity of an item in the world, right? A room or whatever. Maybe I could call it examine content. Maybe I could call this examine examine text. Like if the user wants to look more closely at something or examine or inspect something, we read them this text. And the idea would be when you enter a room for the first time, maybe has visited, maybe, well, anyway, that would actually be a property of the player, not a property of the room. Because it's going to be multiplayer eventually. Anyway, so maybe there's a list of visited rooms or something. Anyway, when you visit a room for the first time, it would go ahead and examine the room. But when you visit again, it just shows you the label, you know. And a cool thing I've seen on some games is where when you enter a room for the first time, it only shows you the detailed description. And when you enter it for the second time, it only shows you the label. So it's almost like you kind of memorize the label by, like, when the second time you go into a room, you memorize the label because you're like, wait, what? Oh, that room. I know what room they're talking about. And of course, if you can't remember, you can always examine again to get the room description again, get the full room description. But like that first time, when you see label for the first time and you're like, I'm supposed to figure out what this means, it's a little puzzle, it helps you remember it. Anyway, all of that. And yeah, I hope you guys have had fun. This is where we're going to stop for today. And man, I'm super excited to come back. So I really hope you all will join me next stream. And until then, take care. I think I did that wrong.